Some aluminum cans are filled with boiling water as shown in the two setups below. The temperature of the water in each setup is taken and recorded using a data logger over a period of time. So we have a data logger here and two temperature sensors. One with just one can filled with boiling water and the other with 7 cans all filled with boiling water. So we know that which of the graphs shows the table. Okay, I'm not going to show you the graphs because I need you to figure this out. If let's say we have we have a graph. Okay, one is okay. We know that this is what we change. This is time, in fact. Okay, so this is time, right? And this is the amount of heat. You know, this is time, and this is the temperature. Okay, we start from 100 degrees. So if this is 0, then 100 degrees. Oops. If this is 0, then 100 degrees has to be somewhere here. Okay. So if this is 100 degrees and this is 0, it is boiling, so the water needs to be from 100 and it will go down, right, all the way to room temperature. So this is room temperature, should be somewhere here, right, from 0 to room temperature. Okay. All right. So, but the question then is, how do we, which one, this is setup 1. Now, if we have only one can, that means heat would be able to escape, right? Oops. Okay, if this is one can, it means heat is able to escape to the surrounding air quite fast, right? And the can will be cooled down to room temperature as shown in the diagram. Now, but what happens if the can is surrounded with other cans that is also filled with boiling water? So that would mean that the can needs more time to travel out, right? Sorry, the heat from the inner can would need time to travel because it is surrounded with warmer objects. Alright? Because it has to go through all this, and this is also losing heat. Okay, and because this is losing heat, the inner can would need to wait for all the surrounding cans to lose heat first before it starts to lose heat. So with that in mind, do you think that the temperature that the can in setup 2, the inner can in setup 2 will lose the heat faster, or do you think it will lose the heat slower? So if it loses heat slower, okay, it will be like that. It will reach longer time before it reaches the same amount of heat. Right, it will be like that. That means at any point in time, if you read the passage, if you read the graph, you will see that the heat will always be higher than in setup 1 because it is taking a long time. Eventually, it will reach the same room temperature, but it will take a longer time. You see, it's a longer time here, right? It's a longer time here, right? You see that? Compared to the same room temperature. Okay. Now, but it could also be, if it is much faster, it will be, sorry. So it is much slower, so it will be something like that, right? Why? Because heat travels from an area of higher temperature to an area of lower temperature. In this case, it is surrounded with an area of the same temperature, so the heat from inside the can will find it harder to travel outwards. Okay, so because of that, the graphs will be something like this. Okay, thank you.